Hey everyone, Geek37 back with another video, and in this video today I am going to do the product of sine of pi over 7 times the sine of 2 pi over 7 times the sine of 4 pi over 7. And this can be a bit of a difficult calculation. So what I'm going to do first is I'm going to convert the sine ratios that I had in my last video into their squared analogs to make this a bit easier. And I am going to cut some of the algebra down because of time and space constraints. Now, as you can see here, sine of pi over 7 is equal to the square root of 4a squared minus b squared over 2a. I'm going to square that, and then I'm going to do the fraction reduction. So we'll get 1 minus b squared over 4a squared. Now, on the sine of 2 pi over 7, we got the square root of 4b squared minus c squared all over 2b. The analog of that squared will be 1 minus c squared over 4b squared like that. And similarly, for the sine of 4 pi over 7, it is the square root of 4c squared minus a squared all over 2c. The analog of that squared with the algebra being reduced will be 1 minus a squared over 4c squared. Now off to the right here, I have sine squared of pi over 7 times sine squared of 2 pi over 7 times sine squared of 4 pi over 7. I'm going to write their algebraic components over here. Now, just so you remember, this is all about the heptagonal triangle, and we're trying to find the product of these three signed ratios. And if you remember, the shortest side of the heptagonal triangle is a squared, the medium side is b squared, and the longest side is c squared, and they are opposite the angles. Side A is opposite pi over 7, side B is opposite 2 pi over 7, and side C is opposite 4 pi over 7. I'm not drawing that here because, again, of time and space constraints for this video. Now, here's what's going to happen. What I'll do is, again, I'm just going kind of through the algebra quickly on this. So if we do the FOIL method on this, we'll get 1 minus c squared over 4b squared minus b squared over 4a squared. And I won't show the cancellation on this, but if you multiply negative b squared over 4a squared times negative c squared over 4b squareds, the b squareds will cancel. So we are left with b squared over 16a squared. Now, what we'll do is we'll multiply that out into the next part here because we have 4 terms in the first parentheses and 2 terms in the last parentheses. We're going to get a large algebraic expression with 8 terms. We're going to start out by multiplying 1 times 1, so we get 1, and then we'll take the 1 through and we'll first to the first set of parentheses, and nothing will change here because 1 times anything is just the anything that is left. Now, this might be a bit confusing, but again, for time and space constraints, you'll just have to follow along. We're going to take 1 times a squared minus 4c squared. That won't change. And then we'll multiply the a squared times 4c squared going through here. To the second term, the c squareds will cancel, and we are left with plus a squared over 16b squared. And then on the next term, when we multiply through, the a squareds will cancel. So we'll get plus b squared over 16c squared. And then on the last term, what will happen is b squared times 16a squared times negative a squared times 4c squared. What will happen is the a squareds will cancel. The a squareds will cancel, and the oh, I'm sorry, that's my bad. That should be ac squared up there. Give me 1 second here while I erase that. That was my bad. So that right here is c squared over 16a squared. Did I get the right components down here? Yeah, I did. The exception here, this one here is c squared. My bad. Dang it. Sometimes you're going through this quickly and you make mistakes. Got to be careful of doing that sometimes when you're doing a video with a lot of algebra, and I'm glad I caught that when I did. So, we got 16c squared over 16a squared minus 4a squared over 4c squared plus a squared over 16b squared plus b squared over 16c squared. And now when we multiply the last terms, the c squareds and the a squareds will cancel, so we'll get negative 1 over 64. Now, to speed through this algebra a little quick, we're going to take 1 minus 1 over 64. That's pretty easy. You will get 63 over 64 because 64 over 64 is equal to 1. Next, here's what's going to happen. I'm going to group these as follows. I'm going to pull out a 1/4, and what we'll get, what is left behind is c squared minus b squared plus b squared over a squared plus a squared over c squared. And then in the last part, it's going to be 1 over 16 times c squared over a squared plus a squared over b squared plus b squared over c squared, just like so here. Now, those those quantities that have the squared components in them, I did 2 videos on where those numbers came from. And if you go back in my playlist on the heptagonal triangle, you'll see where those come from. Now, if you remember, the c squared over b squared plus a squared, b squared over a squared plus a squared over c squared multiplied to be, they worked out to be 5, plus in the video that came after it, the c squared over a squared plus a squared over b squared plus b squared over c squared came out to be 6, just like that. Now, we'll go through and we'll find a common denominator, which is 64, because 4 and 16, when they multiply, they get 64. So we'll get 63 over 64. I will do I'll just do a quick 80 over 64, because 16 times 5 is 80, and 16 times 4 is 64. And then, of course, we got the 6 over 16. Multiply that by 4, we get 24 over 64, and that works out to be 7 over 64. So this is the signed squared version of it. Sine squared of pi over 7 times sine squared of 2 pi over 7 times sine squared of 4 pi over 7 will equal 7 over 64. But no, I was actually looking for this calculation. Sine of pi over 7 times sine of 2 pi over 7 times sine of 4 pi over 7. Well, the thing is, those are the regular versions. They are not the squared versions. So what you're going to wind up doing is if you take the square root to that entire boxed off expression, you'll get the result here. And what will happen is you'll get the square root of 7 over 64. 7 is not a perfect square, but 64 is. So you get 7 over 8. So the sine of pi over 7 times the sine of 2 pi over 7 times the sine of 4 pi over 7 is equivalent to 7 over 8. And I always have found that calculation quite fascinating. Now, there's another part of this video that I need to put up, so give me a second. So as you can see, I have cleared out the upper left portion of the screen to put in these 2 other calculations. And the other thing I wanted to mention was that the sine of 3 pi over 7 was equivalent to the sine of 4 pi over 7, because that's equal to the sine of pi minus 3 pi over 7. I showed this in one of my last videos. So what happens is, because of sine of 3 pi over 7 equaling the sine of 4 pi over 7, if we were to take the squares of those ratios, we would get the same answer as over in the box there on the right side of the screen, 7 over 64. Therefore, the sine of pi over 7 times the sine of 2 pi over 7 times the sine of 3 pi over 7 gives us the square root of 7 over 8. And that's what I wanted to show you today in this video. What we're going to do next in our list of videos for this section. Sorry about that. I misplaced the page of my schedule for uploads. What we're going to do in the next video is we're going to find the products of the lengths of the sides of the heptagonal triangle, and it's going to come out to a nice, simple expression that won't take very long to derive. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.